Bismillahirrahmanirrahim. Good morning, everybody. I am going to present to you my final project in Data Scientist Project Test Internship Program by Rakamin Academy, collaborating with Kalbe Nutritionals. Here is the outline of my presentation. First is introduction. The second is methodology. The third is results, and the last is conclusion. Let me introduce myself first. My name is AuliaKurniasih. And as an engineering graduate, I am fueled by a deep passion for data science and insatiable curiosity to unravel its mysteries. I immerse myself in self-study by online courses and practical projects. My unique blend of engineering acumen and data-centric mindset empowers me to contribute meaningful to the dynamic landscape of data science. My experience is I have already taken IBM Data Science Professional Certificate by Coursera from June to September 2023. And right now I am volunteering at Data Science Weekend for the upcoming event in November. And right now I am following this project-based internship at Kalbe Nutrition. So the case study is as a data scientist at Kalbe Nutritionals and currently getting a new project from the inventory team and marketing team. I'm using the tools Python, Jupyter Notebooks, Tableau, the Beaver, and PostgreSQL. And for the marketing team, I am going to create a customer cluster or segment based on several criteria. The first is the goal of this project is to create customer segment, and the second, the customer segment will later be used by marketing team to provide personalized promotion by sales department. And for the inventory team, I'm going to help them to predict the number of sales or quantity from the total of all Kalbe products. The goal of this project is to find out and estimate the quantity of products sold so that the team inventory can create daily inventory sufficient. And the second is to make a prediction what product must be made daily. So, the methodology. The first is data ingestion to the Beaver. The second is exploratory data analysis in the Beaver. The third is data ingestion into Tableau Public for visualization. The fourth is to create a dashboard in Tableau. And the last, to create predictive regression and clustering models. Data ingestion into the Beaver and exploratory data analysis. The first is to answer the query about how much is average age of the customer from the marital status. So I'm going to use this query using the case that when marital status is known, then it's labeled as unknown, and we're going to count the average age from the customer table and group by the marital status. The result is there is three different categories. The first is unknown, and the average age 31 years old. The second is married. The average age is 43 years old, and the single one is 29 years old. The second query is what is the average age of customer by its gender. So I'm going to define the case when gender is null, then it's female. When the gender is 0, and when the gender is 1, then it's male. And we're going to count the age as average age from the customer table and group by its gender. So there is two gender. The first one is male. The average age is 39 years old. The second one is female. The average age is 40 years old. The third query is to decide which store with the most total quantity. And we're going to select this store name from the store table, and we're going to summarize the transaction quantity, and we're going to label it as total quantity from store table. We're going to join transaction with the store data with the key is store ID, and we're going to group by the store name, and we're going to order the spending from the total quantity, and we're going to limit it into this one. So the most quantity from the store is Linga with a total quantity of 2,777. And the fourth query is to decide which product it sells the most with the most total amount. So we're selecting the product table, column product name. We're going to summarize the transaction table from its total amount, and we're going to label it as total amount from the products table. And we're going to join the transaction data with the product data with the key is product ID, and we're going to group by the product name and order by total amount, the spending, and limit it into this one. So the product name which sold the most is just it. The total amount is 27,615,000. So we're going to get ingestion to tabular public and create a dashboard in Tabular. The daily transaction as you can see in these graphs, it is fluctuative and literally similar month by month. We can see here that is a significant increasing in the March, and the product sales that sells the most is Thai tea, and the least is cashew, and total sales per store the most is in Lingga, which is in Ambon, and the least sales there is in Kalimantan. You can see here is the distribution of the store in Indonesia. So we're going to create predictive regression and clustering models. First, we're going to import all the labels that we needed using pandas, numpy, matplotlib, seaborn, and warning. And from skill and preprocessing, importing standard scalar to make the data similar in scale. And for clustering, we're going to import k-means. For the regression, we're going to import Sarimax and PMD Arima. For finding optimal number, we're going to making inertia with k-means and plotting the figure to know what is the great k-means to use for the clustering method. It turns out that the cluster is 3, so we're going to use that number to make a cluster model. And for the regression, we're going to split the data first. We're going to split the data first, and we're going to using Arima, and then we're going to import Sarimas, and we're counting the root mean square error. The RMSE is 14, and we're going to forecast the data for the period of 90 days ahead. And last is we're going to plot the forecast. Here is the result. For the predictive clustering models, you can see that the inertia that show non-significant graphs is in the 3 number of clusters. So we're going to use that, and we get 3 clusters. The first is cluster 1 with the color of purple. The second one is cluster 2 with the color of blue, and the third one is cluster 3 with the color of yellow. Cluster 1 is the largest number with customers that have a high matrix. A customer with the second ranks in each matrix, and the third one is customer with the least or the lowest position for each matrix. And for the predictive regression models, we're going to use this 80% of training data and 20% of test data, and the result is this predicted data. It's around 50 pieces sales or transaction for the next 90 days. And for each product, we can see that there is a variance in the sales. So we can conclude that the cluster 1, with a large number of customers with the characteristic occupying third place in each metric, both in terms of transaction quantity and total amount. So the recommendation is to build a good relation with customer and conduct surveys to find out the interest of the majority of customers. The second cluster, with the number of customers with characteristics ranked second in each metric. The recommendation is to provide promotion regularly to increase transaction and increase sales of high-priced products. The third cluster, with the number of customers with characteristics occupying the lowest position for each metric, the recommendation is to provide significant discount to attract and increase customer transaction, over promotion on transaction with higher quantity of goods, and conduct survey for potential product development. By using 80% training data and 20% test data, in general, the sales data that can be predicted for the next 90 days is an average of 50 transactions per day. The predicted quantity of transactions per product is chocolate bar 6 pieces, ginger candy 5 pieces, yogurt 4 pieces, crackers 3.5 pieces, Thai tea 3.4 pieces, just steak 3 pieces, potato chips 2.7 pieces, cashew 2.4 pieces, and oat 2 pieces. Here is the link that I provide to my Tableau and GitHub. And thank you for your attention.